All right, guys, we're going to jump into imaginary numbers today. Ooh, imagination. It's something wonderful. Anyway, I'll stop messing around. Really, we're just talking about square roots of a number, and you understand that the square root of a number, perfect squares have square roots. And if it's not a perfect square, we just leave it in the radical. If it's a times b, we can break it up into square root of a times square root of b. And so I'm going to do a real simple one for you here. And I'm going to say, I'm going to start with the square root of 4, right? Well, we know that the square root of 4 is 2. Why? Because 2 squared is 4. So if we undo that square by using the square root, there we go. Now, that's not a big deal. But what if? What if we have the square root of a number, but it's not a perfect square? So let's use, just because I had the square root of 4, let's do the square root of 20. Okay, and we're talking about factors of 20, right? Well, 10 and 2, and 20 and 1, and 5 and 4, right? Well, of those, which is a perfect square, right? So 4 is a perfect square, so we could actually take the square root of one of those factors. So up here it says that this value 20 can be broken up into the square root of 5 and the square root of 4. I'm actually going to write it the other way around. This can be broken up into the square root of 4 times the square root of 5. Okay, well, one of them is a perfect square. So we can actually take the square root of that. And that's how we simplify radicals. And we did some of this earlier this year. I don't know if you remember it. I think I got a ton of complaints from people, so we didn't focus more on it. But here it is, in a nutshell, simplifying a radical. But here's what happens. It says up here that, oh my God, what if I have a negative in the square root? And now I can't have a negative square root. Well, they have fixed it by creating this term, I. So let me just get rid of this stuff. And delete. Get rid of that. Put that away. And so they said, all right, for those of you who think that this is insane and we shouldn't be able to have negative square roots, we're going to give you a value and we're going to call it I. Not I for imaginary, just I. Okay? And I squared is going to be negative 1. Well, what happens if you take the square root of I squared? Let's just do some math. Okay, take the square root of I squared and take the square root of both sides. And now I, because we don't really know anything about the square root of a negative, we have, oh my gosh, look at, I just wrote a square when I just took the square root of it. Silly. There we go. That's more like it. So I equals the square root of negative 1. So these are two values that we need to know cold. Why? Because we're going to be looking at quadratic equations, and we're going to have to use those two values. So what I'm going to do is I'm going to get rid of the piece that showed how to solve it, but I'm going to leave those two values sitting next to each other. I should just move it, but I'm too lazy to do the extra stuff, so I'm just going to rewrite it. I'm just going to say that I equals the square root of negative 1. And now we know this. And now we can use this for good instead of evil, right? Our job is to blot out evil. All right, so here's a problem. And this is on your study guide sheet. We're going to look for the answer to this. What is the square root of negative 72? Well, the square root of negative 72. First of all, I know that I'm going to have an I in there. And I can break up 72 into a couple of factors, one of which is a perfect square. And by the way, 72, when you cut it in half, breaks up into the square root of 36 times the square root of 2, right? 2 times 36 is 72. And I'm also going to break it up into the square root of negative 1 to take care of that negative sign there. Okay, so now we have a couple of things we can take the square root of, or at least we have a value that we can stick in there. We're going to take the square root of 36, and we know that that is equal to 6, because 6 times 6 is 36. We can't do anything with the square root of 2. It is what it is. That's it. And then, because we have that square root of negative 1, we're just going to stick an I on the back side. All right? And that is a perfectly valid answer to our query. What is the square root of negative 72? All right? Okay, so we've got this part down. And I'm just going to erase that so we can get to the next part. We're going to FOIL. Don't you guys love FOIL? You have to love FOIL. So I know I left a tiny bit of a mess, but I don't really care right now. Those of you who are OCD, I really, really, really apologize, but I want to move on. I want to multiply 2 plus I by 2 minus I. Oh my gosh, and this is where that I squared is going to come in, isn't it? Okay, well, I'm going to FOIL the whole thing out, even though you don't have to do the middle because it's a difference of squares. And if you already know that this is a difference of squares, you can leave the middle term out. You're going to see that the middle term will cancel. FOIL says do the firsts, right? Multiply 2 times 2, which is 4. Then it says multiply the outers. And 2 times negative I is minus 2i. It's just like any other variable. You don't do anything with it. You just multiply it by 2. And then the inners. And that is plus 2i. All right? And then lasts, which is I times I. And when you multiply a variable by another variable, sorry, it's I times negative I, but one variable times another is squaring that variable. So it's 4 minus 2i plus 2i minus I squared. Now, we have a value for this, and we are going to evaluate this like that. All right, so first things first, 4 minus 2i plus 2i, they are opposites of each other, so they're going to cancel each other out. Then we're going to have minus, and I squared has a value, right? It equals negative 1 minus negative 1. And really and truly, we could put those together. Minus and negative is plus a positive. So this whole thing equals 5. All right, so we just simplified this to the number 5. Silly, isn't it? But that's how it works. All right? The next thing we need to do, and I made a mess up here, so I'm really just beside myself that I have to get rid of this and then have a big mess left over up there. I'm really disgusted by this. Anyway, I wanted to be able to teach you something, so I'm moving on. We have this wonderful idea, and it says, what is 5x squared plus 45 equals 0, and it means solve for x, right? So, we're looking for values of x. So let's go ahead and see if we can find a way to make this work. Here we go. You can factor out a 5, right? You can divide each of these by 5. So it's 5 times x squared plus 9 equals 0. Now our problem is this. This is where I comes into play. This is where, if you look at it, it looks super simple. And it looks like, hey, I can find this lickety-split. This should be the easiest thing I've ever done in my life. But when you factor this, you have a problem, right? So when you take the square root of these things, you're in a heap of trouble. Now, I'm going to tell you a secret. If this were the x squared minus 9, it would have been super simple, because we know that x plus 3 and x minus 3 would equal x squared minus 9. All right? But that's not the case. I'm going to tell you right now. If you run into a situation, say it's x squared plus 25, you can't easily make this work unless you are using imaginary numbers. So this is, believe it or not, x plus 3i times x minus 3i. All right? Because we have addition here, we have to have that extra negative. If you FOIL this out, you will come up with this. Remember, I showed you without the I, this ends up as a negative or a minus 9. But that's what this looks like FOILed out. And I will work more with you in class on this. This is a really tough one. But it's not such a big deal that you can't do this. The other thing that you could possibly do is you could use the quadratic formula, but why use the quadratic formula if you don't want to? What we're trying to get you into the habit of doing is seeing certain patterns. So I'm going to do one more of these. I guess I'm not, because I'm not doing what I wanted to do. There we go. I'm going to delete it and going to get rid of it. So I'm going to do one more of these. Let's try, just for fun, 4, x squared, okay, this will be kind of cool, plus 24 equals 0. And of course, we want to get, we want to factor out whatever we can. So we take out the 4, we divide by 4, and we still have x squared plus 6, right? Because when you divide 24 by 4, you get 6, and that equals 0. And we haven't solved for x, right? So I'm going to show you the really cool way to do this without thinking about factoring. Are you ready for the fun? Just solve x squared plus 6 equals 0. So you subtract 6 from both sides, right? And I'm going to rewrite up here. So now I have x squared equals -6. Now I'm getting closer. Now I understand what I'm supposed to do. Let me undo that. Let me, instead of rewriting, I'm going to use a different color. How about that? Now I'm going to take the square root of both sides, and now I have, now I have x, but in here I have, oh, wait a minute. I have the square root of 6 times the square root of -1. Well, I know that the square root of -1 is I. So what I'm going to do is something that I can take the square root of, I'm going to put in front of the radical. Something I can't take the square root of, I am unable to take the square root of, I'm going to put it in the radical behind anything that I was able to take the square root of. And so that's my answer to this one. So when we go back to the other problem that we did, it would have been much easier to do it this way, wouldn't it? Instead of playing detective, which you guys hate anyway. You hate when I tell you to do that anyway, right? So, I apologize for ruining your lives. I know you hate it. But how come it won't let me erase? Anyway, there we go. So if I go back to that last one, and we got to x squared plus 9 equals 0. We subtract 9 from both sides, right? And that goes away, and that becomes 9. And x squared, -9. And then x squared equals -9. And then we take the square root of that little fella. We take the square root of that fella. Now we have x equals, well, let me break it up just for fun. The square root of 9 and the square root of -1. So we have values for both of these. Oh my gosh. I need to show you something fun, right? When we do this, we use this symbol. Anybody know what this symbol is? If you do, then congratulations. It says plus or minus 3, right? Because if I square -3, I get 9. If I square +3, I get 9. So we don't know which one it is. And when we're solving quadratics, we don't really know for sure when it's a perfect square like this. And there we go. That's how we got our plus or minus 3i. Anything else before I move on to the other section? That's that for now, and I'll give you the rest of this in just a moment.